Hello, geometry kids. We're going to start going over chapter 10 review, but you know what? First I want to talk about, and yes, I am on location. I'm on location at the school. But first I want to talk about what you need to make sure you know for tomorrow. So let us brainstorm. I got my little list here to make sure. Number one, you need to know all the formulas. So right now, if you can, you should pause and see if you can write them all down. Actually, I'll say them and then we'll see if you know them. So you should have area of a rectangle. You should have area of a square. You should have area of a parallelogram. Should have area of a triangle. So hopefully you're writing them before you're checking with mine. Should have area of a, let's see, what else did we do? Trapezoid. Should have area of a kite. Should have area of a rhombus. Should have area of a what else did we do? Polygon, a regular polygon. Area of a circle. Circumference. Of a circle. Wow, how about I get on the screen? Sorry, guys. Well, that's all right. You're writing them anyway. Hopefully. God, I don't think I missed any. Okay, so in addition to all these, you also need to know the triangles. You need to know the 30, 60, 90 triangle. By heart, you need to know the 45, 45, 90 triangle. By heart, you also need to know how to use SOHCAHTOA. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Let's see, the other thing you need to know is when we are talking about arcs, when they say measure of arcs, they're talking about the degree measure. When we're talking about the length of arcs, we're talking about the distance. So you would want to be dealing with what? The circumference. Okay. So those are the most important things. A lot of these hopefully you knew coming into the class. There's some basic formulas here. Some you didn't know. Memorize them. Make yourself your own sheet. honestly, what I recommend, I'm going to just throw this out there as an idea. Make yourself a sheet and put area of a rectangle, but don't put the formulas in. Put area of a rectangle, area of a square, area of a parallel, like just like I have here. Put two triangles, 30, 60, 90, and 45, 45, 90, but don't label the sides. And then when you get the test, then I'll let you just pull that out and fill all those in right before you take the test, so that you can just have it all there right in front of you. And that'll only take you 30 seconds to fill all that out, but you would have it set up. So you can do that. It's up to you. So again, you can fill this out without the formulas or the sides. And then as soon as we start the test, you can fill them in and have it sitting there for you to refer to. Okay, so there's that. Now, on to the review. It's a tough test, kids. I am going to go through this, but I'm also going to throw in some problems in the middle of this. So I highly recommend you listen to every one. Now remember, if you haven't even done these yet, it's like you're wasting your time. If you start watching this means that you've already done these, you've corrected them, so you know which ones are wrong, and you are now sitting here. If it's something you had right, yeah, you're just watching it for good measure, and you'll be done. If it's one you had wrong, you're paying close attention, then you're trying it again. You're going to put it on a different piece of paper, and you're going to try it again. Can I do it now? Not after watching me do it, after you doing it correctly. Okay? And then plus I have a few extra ones in here, at least 3. So take breaks as needed if you need to take some breaks, okay? Because it's not going to do any good if you're falling half asleep. You might as well skip it. Okay, so let us begin. We are going to start with our basic areas, which is always the fun part as long as you get the right formulas. So, and I'm going to notice that it says round. So, as I've taught you guys to do, I highlight these things so that I don't forget it. Area, this is a triangle. I locate the figure. I write the formula. This gets pretty in-depth and complicated, so if you have been resisting this along the way, showing your work, I highly recommend you begin now, because as you will see, some of these problems get pretty intense with work kind of all over the place. And if you haven't been organizing your work, then it's going to just be that point where you start to get lost. So write the formula, now substitute the values. Remember that the base and height are always perpendicular. So you always got to find those two that are there. So if I give you the 6 and I also give you this side, know that it's the 6. It's the one perpendicular, and the other side has to be perpendicular. So 1/2, the base is always a side, the height is perpendicular to it. 1/2 of 60 is 30. Putting my proper unit with it. If you guys are in geometry, I want you to work on getting proper units with everything, okay? Alright, so let's take a look at 2. I can tell by looking at this, these are equal sides. I know that I've got this, which is 5. I need to get the area of this. So I'm going to start with my formula, which, boy, I could use 2 different formulas here, couldn't I? I could use area equals 1/2 base times height, or I could use area equals 1/2 of the apothem times the perimeter. So I'm going to hold off. I've got 2 options for this, 1/2 base height or 1/2 AP. So I'm going to just kind of see where this goes. I can see that I'm going to need to make a right triangle in here, down straight through, and make the apothem. And if this is 5, let's figure out these angle measures. This is an equilateral triangle because all the sides are the same, so that means that each of the angles, 180 divided by 3, remember every triangle equals 180, is 60. So that means this full angle here is 60. And if I cut it in half, it is 30. Now, if that's 30, that means this up here is 60, and I've got a 30, 60, 90. Okay? So now if this side, I actually make it bigger right here so that you can see it a little bit better, and I recommend you do the same if you're having trouble seeing. So when you're doing this, the 5, remember, is this side. So let's put our x's on there. Opposite the 30 is your x. The hypotenuse is 2x. And this leg is x root 3. So what can I do here? I know that this is my hypotenuse, and that's equal to the 2x. Okay, so 2x equals 5. That means x equals 2.5. So now I know that this side is 2.5 right here. And I know that this bottom part is going to be 2.5, that's my x, root 3. So do I have everything I need for one of those formulas? Yes. I don't know the height, so I'm not going to do that, but I can figure out well, I have the apothem, it's right here. And I can figure out the perimeter now because I can figure out all 3 sides. So I'm going to throw that formula up here. I know which one I'm going to use now. So 1/2 of the apothem, which is 2.5, times the perimeter. So let's figure out one side. If this part right here is 2.5 square root of 3, the whole side is this times 2, which is 5 root 3. That's this side right here. Okay, this one side right here. Now I need 3 of those because it's a perimeter. So I need this, and they're all the same. So now I'm going to times that by 3. And remember, when you multiply them by 3, I'm just multiplying those whole numbers. And I have 15 root 3. Hang on 1 second, please. This is cool because I can pause it. I'm disagreeing on here. My work is disagreeing with what I have on the key, so I'm going to see who was right, me or me when I did the key. Hang on 1 second. All right, I'm back, and the good news is I have decided that that was wrong when I did the key, and this is correct. For some reason on my key I had 7.5, so please ignore that. Not sure why I multiplied that by 3. I did verify, and this is the apothem right here, and it is 2.5. So I kind of just re-looked at it, make sure I didn't miss anything. So now we need to do it to the nearest tenth. So I'm going to grab my calculator here, put it where you can maybe see it. Maybe. There we go. So I have a half, so 0.5 times 2.5 times 15 times 3 square root equal 32.5. Interesting. My answer is right on my wrong answer key, but the work isn't right. That's weird. Anywho, so that's that one. Let's move on. That was right off the bat a tough one, wasn't it? All right. First locate, or not locate, first look and figure out what figure you have. This is, of course, a trapezoid, because you can see the 2 parallel sides. So we're going to start with our formula. 1/2 height times b1 plus b2. All right, so we need to know that the b1 and b2 are always the parallel sides, and the height is always perpendicular to them. So I do have the b1 and b2. b1 is 14, and b2 is this whole length of the side, which is 26. But I need to find the height, which is right here. Now it's just lovely, because again I have a 60-degree angle, so I have a 30, 60, 90. I'm going to go up above it and make my triangle a little bigger for you guys to see. So this was a 60, said this was 6 inches, and here's my right angle. So that means this is a 30. Opposite to 30 is always your x. Hypotenuse is 2x. And the other side across from the 60 is x root 3. So I need that one. Well, the good news is that 6 is equal to x. Whoops, slide that camera up a little. Is that they gave you the one across from the 30. So we know x, it's 6. So to get this height here, it's going to be 6 root 3. So that's kind of slick. That wasn't too bad compared to the other one. And what would this be? This would have been the x times 2. So this would have been 12. Just for good measure, I'm going to put that in there. Don't need it, but oh well. Now we need to solve this. I'm going to just simplify a little before I grab the calculator, because it's easier if you simplify. Half of 6 is 3. So I can make that, get rid of that fraction. I can add those. 14 plus 26 is what? 40. And then I can also multiply right here, so it's 120 root 3. So now I just need to do that. 120 times 3 root equal 207.8, because it's a 4 after it. Okay. Next. Got your figure. I look at it and I see that I have 4 equal sides. That tells me it's a what class? It's a rhombus. So my formula for a rhombus, 1/2 d1 times d2. Now, you know, these arrows are just, you know, can drive you berserk, because on the quiz they meant one thing and here they mean another. So on the test, I'm going to pull up the test and make sure you understand what is what. So don't worry about that. Or if you ever have any confusion, ask. In this particular instance, this 7.5 is just this part right there. So we actually have 7.5 plus 7.5. So that'd be 15 for one of the diagonals. And here, this 8 is this part. So again, I have another 8 right here, so that's 16. Okay, so we're going to multiply this out, but first I want to simplify, because I see that I can do a half of 16 real easy, and that's 8. And then I just have one calculation to put in here, which is 8 times 15, which a lot of you might know already, is 120 inches squared. Okay, so again, I'll clarify on the test what's what with these silly arrows, okay? All right, we go on to the next one, and I notice that I have 2 sides equal that are next to each other and another 2 sides. Remember, that's called consecutive, and that is a kite. A kite and a rhombus have the same area. Formula. So I just need diagonals, and again they they point to this one, so this is a 6, but since it's a kite, now they both don't cut each other in half. As you can see, the long one here doesn't. That's 4 and that's 10, so that's 14. But the other one will cut itself in half. So if that's 6, then that's another 6 right here, and so that would be 12. Half of 14 is 7 times 12. 7 times 12, you also know, is 84. And my units, and we're all done. So some of these can be easy and some are tricky. This one, we look at it. Now, I will say I'm bothered a little bit because there's no markings on here to indicate what figure it is. These should be here, and these should be here to indicate you have a parallelogram. Again, if you're unsure, always ask me. Area of a parallelogram is base times height. The base is a side, the height is perpendicular to it. So even though I have two sides here, only one of these two is perpendicular to this. And it's this one right here. Okay, these are not perpendicular. So my base is 13, my height is 5, and 13 times 5 is 65 feet squared. You're thinking, I want a lot of those like those three, right? But you will see these types of problems as well. The area of a trapezoid is 100. The sum, what does sum mean? Plus. The sum of its two bases. What are the bases? The ones that are parallel. Is 25. What is the height of the trapezoid? Okay, again, this is where the good work is going to come and help you. You're going to start with your formula for area of a trapezoid. How many variables? 1, 2, 3, 4. So we're going to see if we can figure this out. It tells you the area of the trapezoid is 100. So if you would have only written down this side of the thing, where would you have put the 100, right? So make sure you put your full formula, because now you can see that my A is my 100. What is the height? So you're trying to find the height. And then it says the sum of the two bases is 25. So they already added up the two bases right here, and they found out it's 25. So now, we're going to do, these are all multiplied. Okay, the addition now is gone, so I can do half of 25 is 12.5 times height. Divide both sides by 12.5. And the height is 8 feet. It's not 8 feet squared, it's not area, it's a height. Measure height in feet, not feet squared. Okay, and I believe this is time for one of my extra questions that I made up for you guys. So I'm going to take this off and put a different question up. What I want you to do is I want you to pause the video, and I want you to do it. So here, we're doing this first one right here. I want you to pause it so you can see the question. I want you to work it out. I want you to fight with it. Okay, have an all-out fight with this and figure this out, okay? These aren't easy questions, but they are questions that are similar to the ones on the test, and you need to know how to do them. So, then when you're all set, unpause it, and you can see me go through it. But do not just sit back and watch me do it and not have tried it, okay? I can promise you that's not going to help you. Okay, so it says a trapezoid, I'm going to go ahead and do it, so pause it if you haven't done it yet. A trapezoid has an area of 87. The height of the trapezoid is that, and the measure of one base is twice the height. What is the measure of the other base? Okay, all I know is it's trapezoid of an area, so I'm going to start with that formula. A trapezoid has an area of 87, so I'll put that in for my area. Equals 1/2 height. What's the height? It says the height is 5. And the measure of one of the bases is twice the height. So I know the height. What's twice the height? 10. What's the measure of the other base? So you have to know how to solve that. And you should be able to solve that at this point in time. Okay? But let's run through it. 87 equals, first thing I would do is multiply these two, 2.5. Okay, I can't just start working in here. Okay, remember it's opposite appendix. I got to get rid of this first. And that's multiplied by that. So I'm now going to divide this whole thing by 2.5. And those cancel. And I'm left with 10 plus B2. I can now drop the parentheses because there's nothing outside of them anymore. 87 divided by 2.5 is 34.8. Now, I'm going to subtract my 10, and I'm left with the base is 24.8. Who got it? Somebody out there got it. Nice job. Include it. Put this, in fact, you can put this, I think there's room on the back of your review if you aren't doing it. Next time, do the other problems, do them right on the back of your review, and then I can see your efforts. All right, so that is that. Back to the review. An equilateral triangle has a perimeter of 36 centimeters. Finds its area to the nearest tenth. Okay, what does equilateral triangle mean, class? That's right, it means 3 sides are equal. So I have an equilateral triangle. I'm going to draw it kind of big here, so hopefully I can. Has a perimeter 36. So if the perimeter is 36, what does that tell you guys? That each of the sides, you divide it by 3, is 12. Find its area to the nearest tenth. Okay. So again, we could be working with either formula, but the apothem, since I'm not given anything from the middle, I'm probably not going to use the apothem one. I'm just going to use the straight up 1/2 base times height, because you already have the base, don't you? It's 12. You just got to find the height. And we can do that. Let's draw it in. So the height is always perpendicular to the base. And since it's an equilateral, those are special triangles, so we know what this angle right here is. There's three angles. They're all the same. So 180, again, we did this before, divided by 3 is 60. So this is 60. That tells you this is 30. So I have a 30, 60, 90, where opposite the 30, that's my x. Opposite the 60 is x root 3. The hypotenuse is 2x. So we can figure this out a couple ways, actually. If this is 12, that tells you your x is 6. Or you could have used this. The hypotenuse was 12, and that's 2 x's, so your x is 6. So either way you look at it. But the part we need is right here, the height. And we figured out x is 6, so it's 6 root 3. So 1/2 times 12 is 6. And now I just need to find it up to the nearest tenth. (36) times 3 root equals 62.4 centimeters. This area, yeah, square. Okay, class, it's been about 30 minutes, and we're obviously still have 2 more pages. It might be a good time for a little break. Go get a drink of water, go to the bathroom, go get a snack, do something. Go do 20 jumping jacks, 15 push-ups, whatever. Okay, get that blood pumping again so that you're engaged in this. Actually, before we do that, it was time for one of my other problems again. All right, so when you come back from your little break, on the back of your review, again, pause this and have a brawl with this problem, okay? Fight with it. Figure it out. Look at it from many different angles. See if you can get this, okay? These aren't easy problems. But this is geometry. I mean, if we were just substituting things into formulas, that's you've done before. That's more entry level. You guys are higher level now. So we got to fight with these other problems. So pause it. And I'm now going to be going through it. All right. The base of a triangle is 2 more than twice the height. Find the measure of the base and the height if the area is 20. Well, that sounds like a joy. It doesn't even give us any of the sides. That's okay. That's okay. We don't have to panic, people. Let's draw a triangle. The base of a triangle, so I'm going to use that as my base, is 2 more than twice the height. Okay, so I'm going to put the height in. That's my height. And it says that the whole base right here is 2 more than, that's plus, than twice the height. So twice the height would be 2h, and it's 2 more than that, plus 2. Find the measure of the base, so the actual number, and the height if the area is 20. Well, as we've always known, we start with the formula. Area equals 1/2 base times height. It tells you the area is 20, so put that in. And now, granted, you don't know numbers for your base and height, but they are related because they're both in terms of h. So we're going to substitute those in. So the base is 2h plus 2, so I'm going to make sure I put that in parentheses, because that is an addition sign, and we got to keep the order of operations right, times the height, which is h. Now let's just see what we get when we multiply and get this all simplified. Okay, so we have 20 equals, I'm going to multiply this half through here, so 1/2. Sorry, you guys, I bite in here. 1/2 of 2h is h. 1/2 of 2 is 1. That's still in parentheses, though, because I got this other h out here. I'm going to multiply that h by both now. I could have done it together, actually. I'm just saying I could have done this, had the 1/2 h in front. You know, put that h out front with that, and then I just done this one time. So when you multiply these two, these would cancel, and you'd get h squared. When you multiply these two, the 2's would cancel, and you'd just get h. And that's what you're going to get right now, h squared plus h. You can see this is looking kind of fun, isn't it? So I've got a quadratic now. And when we have quadratics, we have to use the solving techniques that are still on the board from algebra. The factoring, the graphing, completing the square, the quadratic formula, etc., etc. Now you're going to look out here because this is going to be pretty slick. I'm going to get them all on the same side first. Okay, so I'm going to rewrite it. equals what? If I move this over here, what's left over here? 0. That looks like a perfect setup for box 1. So what plus what equals, and then remember it's the number before this. So the number before this is a 1. And what times what equals the second number right here. This is the one you're going to have to remember for the test, box 1. So we got to think of factors of 20. So we have 1 and 20, 2 and 10, 4 and 5. That's it. Which combination of those would somehow give you a 1, whether you add or subtract them? Those. So how would that work? Because I need to get a positive 1 and a negative 20. So I'm going to do a 5 and a negative 4. Does that work? Yes, it does. Remember, these are then gone. This is, and these two. H plus 5, H minus 4 equals 0. Still not done though. I mean, I'm looking for my height. Remember, we're doing this to solve this quadratic. Now, what makes these 0? If this times this equals 0, that means one of these has to be 0. So what would make this a 0? Negative 5. What would make this a 0? 4. Right? 4 minus 4 is 0. Negative 5 plus 5 is 0. Problem is, this is our height now. One of these is our answer. Well, I'm pretty sure the height is in a negative 5 centimeters. So that's gone. Then I have my answer for the height, which is 4. What units are we talking? Feet. And now if I know the height is 4 feet, I can figure out the base. 2 times the height plus 2. So that would be 8 plus 2 is 10. Therein lies the fun of geometry and algebra mixed together. I'm sorry, you guys. So may I recommend, if you didn't get it, you come back at the end of the review and try it again. Just get back to where the problem was listed without the work and get a new piece of paper and try it again. All right. Find the area of each polygon. Round your answer to the nearest tenth. Oh, I just had total panic. I thought I forgot to start the video again and thought all that was without a video. Oh, thank you, Jesus. Okay. Now I'm going to sneeze. This is getting ridiculous now. So they do tell us a key word right here, and it's regular, because we know all the sides and angles are the same. So if I'm going to find the area of a regular polygon, I'm going to use that wonderful theorem I have, which is A equals 1/2 AP. I need to figure out, well, I have this, which is fantastic, because what is this? Is that the apothem? Yes, it is. So that's great. I have area equals 1/2 times 2.8. Just need the perimeter there, and then I will be all set. Well, in order to get the perimeter, I'm going to have to make a triangle. Okay, but I don't know what degree triangle this is. That's the problem. So, if we look at this and we figure out that this is a, remember, 360 degrees around. So I'm going to get a different color. So if I come in here and go like this to all the vertices, just the vertices, I have 1, 2, 3, 4, 5, right? 5 big triangles here. So remember, there's 360 degrees in the middle. So 360 degrees divided by 5 leaves you with 72 degrees. So each of these is 72 degrees. But now notice in here it's split in half. So this is, and I'm going to make this bigger triangle so you can see it. So this little angle right there, I'm going to put it up here, is 36, half of 72. And I know that this side is 2.8. And what side do I need? Remember what we were trying to do? We're trying to get the perimeter. So I need this bottom part right here, because then I can double it, and then I can multiply it by 5. So I need x right here. This is not a 30, 60, 90. This is not a 45, 45, 90. So this means you're going to need to use your trig ratios. Okay, so again, you got it. This is the angle you have, and the one you want is opposite, and the one you have is adjacent. See, this is the hypotenuse, and we're not using it. So we're not going to use either of the ones with the hypotenuse. We're going to use tangent. So tangent of 36 equals the opposite over the adjacent. Now remember, when the x is on top, it's great. You just multiply these two and you have your answer. 2.8 times tan 36. So that, let's do that. 2.8 times 36 tan equals, now that is, let me just make sure I did that right. I don't want to mess up. I'm going to do 36 tan times 2.8. Okay, yeah. So 2.03. I'm going to leave it in there. That's this little x right here, isn't it? So right now I need to take that number and times it by 2, so I'm not clearing anything. Times 2. Now I have this. So now I'm going to take that, because remember I need the perimeter, and I'm going to multiply it by, how many sides are there? 1, 2, 3, 4, 5. And I get that. Okay, so that is my perimeter right here. I just found it. Now I need to take that and multiply it by 2.8. And times a half, or divided by 2, same thing. My answer is 28.5 inches squared. So there you go. It's really important to be super clear and super neat so you don't lose track of what you are doing. Okay? Okay, now we have another one like that, except that in this case, they didn't give you the apothem. See, here they gave you the apothem. Here they gave you the radius of it. Okay. You're still going to need the formula. And in this case, we don't have anything yet. I know I need my A, and I'm going to need my P. So let's go in here and make our triangle like we always do. Make it bigger so we can see it. 8 inches is this. Be careful, because like when you draw the line over it, it almost looks like that's the 8. Just remember what the 8 was. 8 was the radius. And we're going to need both this to figure out the perimeter, and we need this. Okay, I'm going into a sneeze. I'll be back. Okay, I'm going to try, but I am still sneezing. Okay, so the cool thing was these are both pentagons. They're both 5 sides, so we already figured out the angle right here. So we know that this is a 36-degree angle. And if we want this side right here, I'm just going to call that X and call that Y. Two different things, because I need both. X is the apothem. I should just call it A. In fact, I'm going to... I need the apothem. So let's get that first. Again, we got to figure out which ratio to use. So if I'm using this angle, we got the hypotenuse. So we're going to be using these. And this side is adjacent. It's touching that angle. So we're going to use the adjacent one, cosine. So cosine of 36 equals the adjacent over the hypotenuse. Adjacent is A, or hypotenuse of 8. It's in the top, so we just get to multiply. Okay, and I've got my apothem. It's right here. It's not going to fit in there, but 8 cosine 36. All right, then we're going to look at the perimeter, which is y. So that's the opposite in the hypotenuse. That's sine. So sine of 36 equals the opposite over the hypotenuse, which is again slick because it's in the bottom, so I can just multiply. So that's 8 sine 36. But again, this is y. So what do I have to do with that? I got to multiply it by 2 to get one side. And then I have to multiply that by pentagon, 5 sides, to get the whole perimeter. So let's begin there, and then we'll go and multiply it by this, okay? So I'm going to start there with 36 sine times the 8. Okay, so I just found the y right here. Now I'm going to multiply that by 2. Now I got that whole side. Now I'm going to multiply it by 5. And now I got the whole perimeter. So yay, I got this right here. Now I got to multiply it by this. So I'm going to multiply it by, actually I can see 8 cosine 36. So times 8 times 36 cosine equals, and then I still have to multiply it by half, times 0.5. So that's 152 rounded is 0.2. That's my unit inches. So herein lies the problem. If you start abbreviating anywhere in here with these functions, or these trig ratios, excuse me, you are going to run into rounding errors and getting half off. So always leave your stuff in the calculator and keep working with it, okay? All right. Let's get to some easier ones. What do you say? 11. I think I'm allergic to geometry. I'm not sure. The figures in each pair are similar, so we know the ratios are the same. What's the ratio of the perimeters and the ratio of the areas? Remember that scale change. Sides, perimeters, any length is A over B. Any area is A squared over B squared, and any volume is A cubed over B cubed. So when we look at this, it says what are the ratios of the perimeters and the areas. What's really not too bad. The main thing is you have to remember to simplify them. So it doesn't say which direction to go, so you could go either direction. I'm just going to go left to right. So 14 to 8. There's one side. 14 to 8. I'm going to simplify that, divide them each by 2, and we get what? 7/4. Okay, that is my ratio of my perimeters. Because remember, perimeters and sides will have the same thing. They're both lengths. Now to get areas, I just simply square them. But you got to simplify them first. So that'd be 49 over 16. And there's your answer. Okay, so when we go to this one, again, the perimeters will be the same as the sides. So the perimeter is 2 over 3. The area, I square them now. 2 squared is 4, and 3 squared is 9. 13. I wrote it wrong. I have a different one to do, though, in place of that. So, if you can, here's our last extra problem I have. I want you to pause the video and try it. See if you can get it. Don't come back until you've tried it. I'm watching you. You better be trying it. All right. Okay, the vertex of an angle is 3 times the measure of either base angle. Oh, isosceles. Hello, I missed a very important word there. And it looks like it's also spelled wrong. What am I doing there? Okay, anyway, isosceles. I'm just going to do that so I remember. The vertex angle is 3 times the measure of at either base. Okay, so the vertex is always between the two sides are the same. And then these are your base angles. So if the vertex is 3 times the measure of either base, so that means I could call my bases x and x. Keep it simple. They're the same. This is 3 times that, so it's 3x. Find the area if the measure of the congruent sides are 14. Okay, so that means these are 14 inches and this is 14 inches. I do not know the other one. Okay, but I can figure it out because I know that 3 angles of a triangle always add up to 180. So I have 3x plus x plus x equals 180. So that's 5 x's equal 180. And then I'm going to divide by 5. And x is 36. So now I have my degrees. So I'm going to rewrite this. So now I have 36, and 36 times 3 is 108. This is 14, this is 14. Okay, we're getting somewhere now because we can probably figure out the base and the height of this. Okay, it's not going to be helpful to go this way. We're going to work straight down. We're going to do that right there. Because I know I can figure out using my functions what this is and what this is. Again, why don't I use height where height is appropriate? So that's height. So here's my angle measure, and this is the side opposite it, and this is the hypotenuse. So again, so ta, toa. So opposite and hypotenuse is sine. So sine of 36 equals the opposite over the hypotenuse. So I'm solving for h. So h equals 14 sine of 36. What are we doing? Finding the area. So I never started with my formula. Naughty me. All right. So we got our height. I'm going to put it here. 14 sine of 36. And then now I also need the base. So I got to figure out my x and then double it to get my base. Or I could get the area of 1 and then double it too, but I'm just going to stick to this. So if I have this, this is adjacent to the 36, and the hypotenuse, that is going to be my cosine. So cosine of 36 equals adjacent over hypotenuse. Again, that's in the top, that's slick. So I'm going to go ahead and do cosine of 36. I'm going to clear that, make sure nothing was in there. Times 14. Okay, I have this. Multiply by 2 to get the whole base. Okay, so that's right here. I got my base. Now I have to keep multiplying it by this. So I'm going to multiply by 36 sine equals times, and I'm going to do half of 14. I'm just going to do that in my head. 7. And I'm done. Does it say round? It does not say round. Okay, well I'm going to do the nearest tenth. 93.2 inches square. So there you go again. If you had trouble with that, I'd come back at the end to before I did the work, go to somewhere new and try it again. You've got to be able to work through it on your own, not just watch me do it. Okay. Onward we go. Wow, I don't know if it's because I'm struggling so much with my sneezing, but this seems to be taking forever, although it is almost an hour already. A regular 18 gon has a perimeter of 126. To the nearest tenth, what's the area of the figure? Regular is key. And 18 gon tells you, I don't have a special formula for that. So there's my formula for area of a pentagon. The perimeter is 126. Well, that's nice. So I just need the A, and then I'll be able to answer the question. Question is, how do I get the A? Well, we're not going to draw an 18 gon, but we're going to picture that. We're picking that triangle out of the middle of it, where we made this be the what? The apothem. And then this is what? 1/2 of one of the sides, right? And then this is the radius. I gotta pause again. I'm sorry, guys. Okay, so picture in the middle of this 18 gon, right? You got this massive figure with all these sides, right? And in the middle, it's split into these triangles that look like that. How many of these are there? Little triangles in the middle. Right, there's 18, exactly. So how many degrees all the way around in the middle? 360. So 360 divided by 18 is 20. So I now know that this whole degree here is 20. So that means that each one of them right here, that's 10. Which is great. Problem is, I still need a side. So we still need to figure out what a side is, but since they gave us the perimeter, because right now all I have is this and this. I need this, and I have this, but I don't have another side. But they told us the perimeter was 126. So if you took the perimeter and divided it by 18, let's see what that is. 126 divided by 18. That's 7. Okay, so that would be this whole triangle side. Then divide it by 2, and I get 3.5. So So I finally have that side, and now I can figure out the apothem and be done with the problem. So what function will I use? Opposite, adjacent, and use tangent. So in here, it's going to be tangent of 10 equals the opposite, which is 3.5, over the adjacent, which is our apothem. That was the first time we've come to it where the variable's in the bottom. And remember, we can swap these. So A equals 3.5 over tan 10. So we are now going to go ahead and put that in over here. 3.5 over tan 10. Let's do that first. 3.5 divided by 10 tan equals times 126 times a half is 1250.5, and that is the correct answer. That's my unit meters. Okay. The next two problems are using this theorem, which I actually will put on this one on the board. This isn't quite as important. It's to figure out the area of a triangle when you're given a side, two sides, and the included angle using sine function. So it's a different formula. Area of a triangle equals 1/2 BC sine A. I hope I remember to write it on the board. If not, remind me. So area of a triangle equals 1/2, and B and C are the two sides. So 9 and 6 times sine of 118 equals, okay, so half of 6 is 3 times 9 is 27 sine 118 times 27. I got 23.8, which is correct. Good. Next one. It's not a triangle, right? So this is for a triangle, but you can draw a triangle. So go ahead and do that, because since it is opposite sides are the same, you're going to have two congruent triangles. And once you get one, you can double it to get the other. Okay? So a little tricky, but nothing you can't handle. So A equals 1/2 BC sine of A. A equals 1/2 4 and 12 sine 45. A equals 24 sine of 45. 45 sine times 24, 16.97 whatever. I'm going to leave it in there, because what I want to do now is I don't want to round it yet. I want to multiply it by 2 and then round it. 33.9. And why did I round it by, or multiply it by 2? Right, because I have 2 and they're congruent triangles. Good. I think we can move a little faster now on this other part here. So at least the top part. Use the circle at the right. Leave your answers in terms of pi. Name 2 minor arcs. Those are arcs that are less than 180. So you can pick any 2. I'm going to pick JM, put an arc over it, and I'm going to pick ML. Actually, for this one, I wish I would. Let's change that. Major. Can you guys write 2 major arcs? Those are more than 180. L, M, K. JLK. Name one semicircle that's equal to 180. So this is greater than 180. This is equal to 180. MJK. Or you can say MK. You can use either. What is the measure of JM? Remember what I said about measure? It's the degrees. So JM, where is it? JM. So we have to figure out this measure right here. Well, if this is 106, you just subtract it, and you're going to 180 minus 106, and that means that's 74. So that means this arc measure, the measure of it, is 74 degrees. Remember, measure. An arc is a degree. A length is a distance. What is the circumference of triangle W? Circumference equals pi times diameter. What is the diameter? Well, this is 18, so the diameter is all the way across, so it's 36 pi. And it does say leave it in terms of pi, so I am. But I am going to put my units still, inches. What's the length of KL? So this was the measure. This is the length. Got to make sure you don't get those mixed up. I don't want to see a degree for this. So KL. So I need to know what is the distance of this arc. So I'm going to do the circumference, which I have right here, the 36 pi. I already did that. But see, I don't want the whole circle. I only want this part of it. So I need to know how many degrees this is. This is 30. That means this is 150. So that part of the circle. So 150 over 360 tells you how much of the circle I want. Now I'm going to multiply it by my circumference, which I have right here, 36 pi. And that answer is 15 pi inches. Okay. Can do some simple calculating there by crossing the zeros. That's dividing by 10. You also have this over 1, so the 36's cancel. And you're left with 15 and the pi. Again, what's the key word here? Length. Length, not degrees. You may need to use part of the degree like we did up here to say how much of the length are we including. That's the percentage, basically. Okay, so let's look. How much of this circle? Well, it's only 30 out of how many? 360 times the circumference, which is pi times the diameter. That's the radius. The diameter would be another 30, so 60. Okay, again, we can do a little simplifying by divide by 10. Cross off the zeros. And I'm going to end up with 180 pi over 36. And then that also simplifies. 180 divided by 36 comes out even to 5. Okay, and here we're trying to find this darkened one right here. So we're trying to find this length. So again, how much of the circle is that? And it tells you right here, it's 270 out of the total of 360 again, times the circumference, which is pi times diameter. And they gave you the whole diameter here this time, 10. Okay, so I can easily cross out these zeros. Then I'm left with 270. Well, we can simplify that too. Divide them both by 9. And that's going to be 3. That's going to be 4. So I've got 3 times 10 is 30 pi over 4. Simplify it again. That's 15 over 2, which is 7.5 pi inches. Now we're doing area. See, they're different. So up here, when I'm doing length, I'm using circumference. When I'm using length, I'm using circumference. When I'm using area, I'm using area. All right, so it's still the same thought that I still only want part of the circle though. So how much of the circle? I want 45 over 360. But now instead of doing circumference like I did up there, I'm doing area. So it's pi times the radius squared. So 36 pi. So this actually will divide once, and this will go 10 because of the 36. And then 45 divided by 10 is 4.5 pi. But I'm just noticing it does say nearest hundredth on this one. So 4.5 times pi equals hundredths is the second spot. And the number past it is 7, so that's going to make that go up 1. So it's going to be 14.14 meters squared. Okay. Now again, we got to get the area of this part. So we have to get the area. Let me get rid of this because that's just really in my way. That answer over here. I need the area of the sector minus the area of the triangle, and you'll have the area of the shaded. Okay, so we need these two. The area of the sector isn't too bad. Let's do it up here. It's the how much of this whole sector. So how much of the circle is this? It's 90 degrees over 360, which is a fourth, times the area. Pi times radius squared. So 90 over 60 is a fourth. So a fourth times 64 pi. And then that's a fourth and 64 reduced to 16 pi. So I got my area of sector right here, 16 pi. Minus the triangle. 1/2 base times height. Well, the base and the height are the same. They're both 8. Longest video ever with my cold here. 64 times 1/2 is 32. And when I get that, I'm going to have my answer. So let's do it. 16 times pi minus 32. Nearest hundredth, tenth hundredths. The number after it is 5, so that raises the 6 up to a 7. So 18.27 inches squared. Okay, so we have to do this again. This is complicated now. Another one of those tricky ones because it's same thing, sector minus triangle equals shaded. Let's do the area of the sector up here. So the area equals how much of this? Well, it's 60, so we know this is 60. Out of 360 times area pi r squared. Okay, so when I simplify all that, it's 1/6 times 144 pi, which is 24 pi. Okay, so I got the area of this sector, 24 pi. I have to subtract the area of the triangle, and I'll have the area of the shaded. Area of the triangle is a little trickier because you gotta draw in your right angle and figure it out. So area of the triangle is 1/2 base times height. So 1/2. I got to figure out this base. I got to figure out the height. Let's see if I know any of them. I am going to put my triangle right here. I try to draw them in the same direction so that you can see them. So this is 12. If this whole thing was 60, means this is 30. So opposite the 30 is x. Hypotenuse is 2x. Height is x root 3. And if the hypotenuse was 12, then that means x was 6. And this is 6 root 3. So what do I need here? Well, I need to get the area of this triangle. So if I can get this one, I can double it. So this I do have. That is 6. So the whole base right here. Oh my goodness, that's not what I need right now. The area of the base right here is 12. Or not area, the length. So that's 12. Times the height, which is 6 root 3. So half of 12 is 6. Times 6 is 36. Square root 3. So drop down here, 36 square root 3. So I have to do that and get my answer. So 24 times pi is that, minus, I'm going to put a parenthesis. Oops, you can't see me. I'm going to put a parenthesis in because of these two being multiplied together. So I'm going to do a parenthesis and do 36 times 3 root parenthesis equal. And I should get 13, and it goes out to 0.04. So make sure you can get that with your calculator. If you have any trouble, ask me. I can show you. It's a little tricky. Holy heavens. Okay. List 2 pairs of possible side lengths of similar rectangles whose areas have this ratio. Well, remember, if this is the ratio of the areas, 25 to 49, that's the areas. How do I get back to a sides? Square root both of them. So square root of 25 is 5. Square root of 49 is 7. So that could be an example of the sides. It just says a possible one. So there you go. 5 inches and 7 inches. I'll just make up inches. That's one possibility, and that's the easiest one to get. A classmate calculated the area of this triangle. What's the classmate's error, and what's the correct area? They said 24. Well, let me see. I'm going to do it myself. So I got 6. How did they get 24? Ah, I see what they did. So they used the 6 for the height and the 12 and the half, but what did they use? They didn't use the 2, they used the 8. 8 times 6 is 48, and a half of that would give you 24. So they used the wrong thing for the base. They didn't use the one perpendicular. So they used wrong base. Oh, praise the Lord, we're done. That was a long review. Now, even though I struggled through it because of my cold, and I apologize you had to listen to me, but everything's on here. I suggest you try to do some of these problems on a separate piece of paper, some of those difficult ones. You know which ones they are. They got intense and they had different triangles and different things because this is how the test will be. You need to be able to work with 30, 60, 90s, sine, cosine, tangent, different sectors, circumference, arcs. So, all right, folks, take care. Bye-bye.